Hey guys, Mrs. Traver here. We're going to work through notes on our end behavior of polynomials. So we've been talking about polynomials for a little bit now, and mainly we spent our time in chapter 1 talking about quadratics. So we've got this chart going on, and I've got degree as even or odd. So that is the highest exponent that you see, especially if you're in standard form. It's the one on the far left. The highest exponent you see is the degree, and then positive or negative leading coefficient. So coefficient of the leading term is the very first one you see. So if you've got your polynomial with the degree, it's the one that's out front of that highest exponent. So speaking of quadratics, quadratics have to the second power, which is an even degree. So we'll be able to fill in both of these and think about the example of the function y equals x squared and y equals negative x squared. Because we've got an even degree and a positive leading coefficient, there's a 1 right there, an even degree and a negative 1 out there. So these match up to our quadrants. So we know what this function looks like. It is a quadratic like this. Give ourselves a little coordinate plane on the background so we can ground ourselves. And what this is going to help us with is to determine the end behavior of all polynomials, not just at y equals x squared, but this end behavior. Notice how it ends up and ends up. This end behavior of start up, end up will work for every even degree. So for example, I don't want to write this on here, it'll get really crazy. But for example, we could have our quadratic, we could have our quartic, we could have, it's about to get crazy, x to the, I'm sorry, that's to the 4th, x to the 6th, and so on. So notice that all of these have a positive outgrowth, have an even degree, and they just get more wavy as they go. But we know that they all are going to end like this, and we're going to write it really mathy-like. So what we want to write it as is, as x heads towards negative infinity, what does f of x do? So what I mean by this, as x heads towards negative infinity, x is a left or right. So as x heads towards the negatives, I'm really saying as we go left. And then f of x is another wording for y. So f of x does what? Y does what? Y is up and down movement. So as we go to the left, what does y do? As we go to the left, do we go up or down? That's really what this is saying. So if we trace our red line here, if we trace our curve to the left, we went up. So that would be towards positive infinity. Similarly, as x goes towards positive infinity, as x goes to the right, f of x, or y, goes up or down. Well, it went up again, positive infinity. So those are the statements that we're going to have to do for all of these. So let's look at the next one, y equals negative x squared. We know that that's the one that looks like a sad face, the way we talked about it. So we know that everything with a negative coefficient and an even degree is going to start low and end low. So let me fill in our chart. As x heads towards negative infinity, f of x does what? So as x goes to the left, y goes down, so negative infinity. As x goes towards positive infinity, f of x goes towards what? Negative infinity again. So when we end up having to memorize these, this gets a little tricky. I wouldn't advise trying to memorize these things written in black, but if you can think about this equation and this equation and matching your chart, then you'll be in a good spot to figure out what's going on. Also notice even degree is either both up or both down, and the both up one is positive and the both down one is negative. So maybe that'll help to just reason through it. Our odd degree, let's look at a different function. Let's look at y equals x cubed, which is one that's a little bit new to us, and it goes like this. Let me give ourselves a coordinate plane to start. Goes something like this. A little squiggly ass looking thing. So on these guys, notice odd degree, it doesn't go both up or both down. One's up and one's down. So that'll be the deal for the odd degrees. But one is up and one is down. And notice that this one's going to end up and it's positive. So it ends up positive. Let's fill out our chart. As x heads towards negative infinity, so as we go to the left, f of x goes towards negative infinity as well. As x heads towards positive infinity, f of x heads towards positive infinity as well. So these ones match. The other one we can think about here too, that I want to mention, another odd degree that has a leading coefficient as 1, actually I'll put it over here like as if it's part of this chart, is that of y equals x, which we know goes like this. And notice the end behavior matches, so that is reasonable as well. That's another one you can think of. The other example we'll run through is negative x cubed. And that one goes like this. So it starts high and it ends low this time. And lastly, we'll fill out our chart. As x heads towards negative infinity, y heads towards positive infinity. And as x heads towards positive infinity, f of x heads towards negative infinity. So this chart will be one that you'll have to end up memorizing. I hate to say that N word. Let's look at what's going on in the middle here. So we've talked about the end behavior, but let's look at the curves, because we had this like weird example where I was showing you more and more curvy things. What's nice to know is how many times it curves. So that's actually pretty easy to reason through. So here's the deal. If you look at the degree that you have and you take away 1, that equals the amount of curves. Or we could say the amount of turns. So for example, let's kind of reason through these, like y equals x. We know it's just a straight line. This one has 0 turns. So degree is 1, minus 1 is 0, there's 0 turns. And that sounds about right because it's a linear equation. Our next one, y equals x squared. This one, the degree is 2. Take away 1, you get 1. So this one has 1 turn. Y equals x cubed. Degree is 3. Take away 1 is 2. So you have 2 turns. And so on. So we could keep going here. I'll throw one more. Y equals x to the 4th is going to have 3 turns. So you can see here's the 1. Here's 1 and 2. 1, 2, 3. So you can kind of get an idea of how many times you're going to curve throughout if you're trying to find the degree of a polynomial. I want to run through a few examples with you. I'm sorry, this is a longer note section, but there's lots going on. So let's look at a polynomial where I give you the function. So like f of x equals 3x to the 9th minus 15x squared plus 100, say. The only really things I care about is, first off, it's in standard form, so I can just look at this first term. I've got a leading coefficient that is positive, and I've got a degree that is odd. Oops, odd degree. There we go. So let's look at what quadrant of our chart we're in. Leading coefficient positive, odd degree. Leading coefficient positive, odd degree. So it's going to be one that has start low, end high. So if I can think about this from here, then we can end up writing our chart. So we know without really looking at the graph or plotting any points that as x heads towards negative infinity, as we go to the left, we're going to go down. So f of x heads towards negative infinity. And as x heads towards positive infinity, as we go to the right, we're going up. F of x heads towards positive infinity. All right. Let's go ahead and let's utilize this knowledge that we have here. So if I gave you a graph that looked like this, and I wanted to know what is the degree. I'm not even going to give it a coordinate plane in the background. I want to know what's the degree and is the leading coefficient positive or negative. We can tell this by the chart. First off, notice the amount of times it curved. It curved 1, 2, 3, 4 times. So our degree must be 5. And it started low and ended high. Ended high means positive. So that's a degree 5 with leading coefficient positive. Let's do one last one. I saved the best for last. Let's actually go ahead and graph a function. Let's graph f of x equals x cubed plus 3. And we're going to go ahead and give ourselves a coordinate plane as well as a chart. So bear with me while I do that. I'm going to make it nice and big. Let's plot 5 points. So let's do -2, -1, 0, 1, and 2. And then we can go ahead and either use our graphing calculator to find these points or plug it in and do order of operations. I've already done that. So here is our table fully completed. And we can plot those points. So again, I would find these by using my graphing calculator. Most likely I would have typed this into my y equals and then looked at the table to find these, especially if it's like one that's crazier. This one wasn't that bad, but there are some students who make mistakes, especially when cubing things that are negative. So watch out for that if you're going to go old school and do order of operations with scratch paper. So if we were going to graph these points, let me give myself some more markings on my graph to help me out. Okay, so -2, -5, -1, 2, 0, 3, and 2, 11. That's like off the graph, so it's like way up there. So I can kind of imagine I'm going like this, and this one's going to curve up really quickly. So notice that this ended low, started low, ended high. It matched what we assumed it would be. And this kind of looks intuitive because it looks like the x cubed graph we did, but just shifted up a few. So notice that that 0.03 was a translation up because of that. I hope that those all work out. We've gone through a lot in this video, but I think that it was all reasonable. So we've got a lot of information on graphing polynomials now under our belts, and I will see you guys